Okay, so we're going to go through double angle formulas. The very first one, they want us to evaluate 2 times sine pi over 8 times cos pi over 8. Well, what I'm going to do is I'm going to relate this to one of the double angle formulas. Looking at them carefully, it looks like I'm going to be using the formula that says 2 sine theta times cos theta is equal to sine 2 theta. Okay? In other words, these are thetas. Okay? So what we can do is we can go that 2 sine pi over 8 cos pi over 8 is also the equivalent of just sine times 2 pi over 8. Okay? We're just going to solve the right side of the formula now because we've simplified this. 2 times this will give us sine 2 pi over 8, which is the equivalent of sine pi over 4. Well, pi over 4 in our special triangles is our 45-degree angle triangles that are 1, 1, and root 2. Okay? And sine is opposite over hypotenuse, so we're left with 1 over root 2. That would be our evaluated. Okay? Another double angle formula question is this one. Given that tan theta is equal to negative 3 over 4, where we are between, theta is between 3 pi over 2 and 2 pi, find cos 2 theta. Okay, so let's try to make sense of what the heck they are asking us here.
Does that mean it's in the fourth quadrant?
Yes, exactly. It is in the fourth quadrant because 270, or 3 pi over 2, is here, and 2 pi, or 360, is here. So in other words, we're between these values. So we're in the fourth quadrant in this question. Now in the fourth quadrant, let's make sure we understand this, we have cosast. Okay, so it makes sense that our tangent theta will be negative because we know tangent is negative in the fourth quadrant, right? So what we're going to do is we're going to build this triangle here. If theta is our angle here, and we're building our triangle, we always build it from our x-axis, right? We're building our right angle triangle from here. If this is our theta, tangent, primary trig ratio, tangent theta is equal to opposite over adjacent. So in other words, the opposite is our negative 3, right? And that makes sense because we've gone down into the negative version. And the adjacent is our 4. Great. Well, in order to actually find out what cos theta might be, or in this case cos 2 theta, we are going to need to just find out what our hypotenuse is. So we'll call this our c. And there's a really simple way of doing that with Pythagoras Theorem. A squared plus b squared is equal to c squared. So we got 3 squared plus 4 squared equals c squared. We're looking at 9 plus 16 is equal to c squared. 25 equals c squared, which means c is 5. Good. So c is the value of 5. So let me jump back into it. It's a question over here, right? We're going to need our other ratios to also find this, but now that we've set this up, we need to also find out what this angle is. What exactly is our theta? Okay, because if this is the case, we have negative 3 over 4. Okay, we'll need to actually figure out what our theta is in this question. So when we're going about trying to solve this, we know our cos theta, or actually what we're already set up with is for cos 2 theta, let's use our cos 2 theta. We'll use our double angle formula. That double angle formula here for cos 2 theta, there's a couple of them. They've given us 3 versions of it. We'll just use one of them that states cos squared theta minus sine squared theta. Okay, well, in both those cases, we're going to need to know what cos theta is equal to and sine theta. Well, before we even figure out what the angle is, we don't technically need to, because we know all 3 sides of this triangle. Okay, and I'm just going to redraw it down here. We have our triangle now. This is our 4, this is our 3, and this is our 5. And we know we're talking about this specific angle here. Well, I can tell you what cos and sine theta are equal to. From here, cos is adjacent over hypotenuse. So cos theta is equal to 4 over 5, right? And sine theta in this question, and technically, well, because we had that -3, we'll keep that in mind because sine in that quadrant would be negative, right? Sine theta is opposite over hypotenuse, so we're looking at sine theta being equal to -3 over 5, okay? So since we have that, cos 2 theta, well, this, we can replace cos theta with, we know what's 4 over 5. We know that cos theta is 4 over 5. But because it's squared, we're going to have to square that value. And then we're going to be subtracting our -3 over 5. But because sine is squared, we're going to be squaring that value also. So we're going to have 16 over 25. Subtract 9 over 25. That's great. We have common denominators for our fraction. 16 minus 9 is going to be 7. So we have 7 over our 25. Yeah, that's what they got. So for double angles, those are two types of questions they might ask you, and how you have to use those formulas. We have to kind of always keep the formulas handy so that we know what we're going to do with them.